In this problem, we are given a 20 mm diameter steel rod that is 250 mm long, and it is subjected to a tensile force of 75 kilonewtons. If the Poisson's ratio is equal to 0.30, determine the lateral strain of the rod using a modulus of elasticity equal to 200 gigapascals, or that is equivalent to 200,000 megapascals. From the figure, this 75 kilonewton tensile force will tend to elongate the rod. At the same time, it will also tend to deform the rod in the lateral direction, which will decrease its diameter. And to solve for the lateral strain, we first need to solve for the actual deformation. That is, the actual deformation is equal to force P acting in the longitudinal direction times the length divided by the area, or the cross-sectional area, times its modulus of elasticity. Substitute the known values. We have P equal to 75 kilonewtons, or 75,000 newtons, times the length of 250 millimeters, divided by the area, equal to pi times the diameter squared divided by 4, times the modulus of elasticity, that is equal to 200,000 megapascals, or Newton per millimeter squared. Solving, we get P equal to 75,000 times the length of 250 millimeters divided by the area of the circular shaft, that is pi 20 squared divided by 4, multiplied by the modulus of elasticity. Solving, we get 0.298 millimeters. Now let's solve for the strain along the longitudinal direction. Let's set the strain along the longitudinal direction be E sub x, and the lateral direction be E sub y. We have E sub x equal to the stress divided by, strain is equal to deformation divided by the original length, that is equal to 0.298 millimeters divided by the original length, that is 250 millimeters. We get the strain along the longitudinal direction, that is equal to 1.194 times 10 raised to the power of negative 3. And to solve for the strain along the lateral axis, we make use of the concept of Poisson's ratio. That is, the Poisson's ratio is equal to the strain along the, that is perpendicular to the applied force, E sub y, divided by the strain acting along the longitudinal direction, that is E sub x, and the value here is negative. So we have 0.3 equal to negative E sub y divided by E sub x. That is a value of 1.194 times 10 raised to the power of negative 3. Solving for strain, we get E sub y divided by E sub x that we have solved earlier. Shift solving, we get the value of negative 3.581 times 10 raised to the negative 4, and the unit here is dimensionless because strain is a dimensionless unit. And that is our final answer.